Hello guys, welcome to Alpha Maths and Science. Okay, so these physical sciences paper one that you requested. So I arranged you multiple choice. I will do a special video explaining how you must answer multiple choice. So this section B, question two. It says a small metal sphere A carrying a charge of -4 is placed on an isolated stand. You see. So first question, which is 2.1. It says where the electron added or removed from sphere A. Remember, carrying a charge of negative and was placed on an isolated stand, so they were added. Because why they were added? Because the charge is already negative. What about if the charge was positive? That will be removed. Okay, I hope you get that. And then 2.2. How does the number of protons compare with the number of electrons in sphere A? Write down only less than, greater than, equal to, and give a reason for your answer. So, so my answer is less than. Okay, less than. And then my reason is that this is a negatively charged sphere. Okay, negatively charged sphere. That is my first reason. For a negatively charged sphere, for a negatively charged sphere, uh, protons will be less than electrons. Okay, so or I can say it has more more electrons than than protons. Okay, so those are my reasons. For 3 marks, you were supposed to write that. You get your beautiful 3 marks. And then 2.3, they say 10 to the power of 18 electrons are now added to sphere A. Calculate the new charge on sphere A. It's simple. We use this formula. N is equals to Q divided by what? Divide by electrons. Okay. So what is number of electrons that are added? It's 10 to the power of 15 is equals to, we want the new charge Q. What is electrons that this charge is having? Or what is E? You can go to information sheet. You are going to find it. It is what? It is 1,6 multiplied by 10 to the power of minus 19. Okay, minus 19 is there. You don't have to calculate it. Okay, minus 19. So from here, you just multiply. So Q is equals to 10 to the power of 15 multiplied by 1,6 multiplied by 10 to the power of negative 19. Press your calculator. You are going to get negative 1,6 multiplied by 10 to the power of minus 6. Are we done or did we answer the question? No, this is the charge, or this is the charge that is added actually. Okay, so we have, for a new charge, we must say Q plus what? Plus QA. So what is QA? It was minus 4 what? Is it nano? Okay, N means nano. It's 10 multiplied by 10 to the power of minus 9. Okay, if we were given something like micro, this means multiply by 10 to the power of minus 6. I hope you see the difference. And then it means it's 4 multiplied by 10 to the power of minus 9. So what are we adding? We are adding this value, this one. Okay, so plus minus 1.6 by 10 to the power of minus 6. And then you press the calculator, guys. The final answer is going to be negative 1,604 multiplied by 10 to the power of minus 6 what? Charge. Even here we're supposed to put charge. This is how we were supposed to answer this question for 4 marks. Okay, I hope you understand it, guys. Okay, let's continue. Let's go to question 3. They say two identical metal, sphere B and C, placed on an isolated stand, carry charge of my positive 4 multiplied by 10 to the power of minus 6, charge and minus 6 multiplied by 10 to the power of minus 6, respectively, as shown. As you can see, the sphere are now tied to each other, and then, as we can see, and then they, after touching, they separate. It was separated before, they touch, and then they separate again. Okay, starting from this part, they touch, they separate. Okay, so 3.1, it says state a law, state the principle of conservation of charge. So the principle state that the net charge, the net charge of an isolated system remain constant during any physical process. During any physical process. That's how we define it. Okay, so let's continue, guys. Please like and subscribe and share this video to your friends. Then click that ring button or bell button so you can be notified. Okay, and then 3.2, it says explain what will occur as the sphere touch each other. Explain this reaction occurred after touching each other. So guys, remember electron B initial, let's come in. B is what? Positive 4 multiplied by 10 to the minus 6. This one is minus 6 multiplied by 10 to the power of minus 6. So to answer that question, what are we going to do? Okay, let me try to zoom back. Okay, here's the question. I hope you can see. Okay, so here's the thing. So they say you must explain what must what occurred as the sphere touch each other. Explain this reaction occurred after touching each other. So this is what's going to happen. 3.2. Uh, electrons, né? Electrons. Electrons move from C to what? To B. Why? Because this is negative, this is positive. Do you know electrons move from negative to positive, right? And then comma until until they are they are evenly, okay, evenly, no, this is the wrong spelling, evenly distributed. Okay, so what is another part? Okay, so what is another part that we have to talk? This is positive, this is negative. Okay, so when they are evenly distributed, we are talking about now they are evenly distributed. Why? What caused these two spheres to separate after? So this is the part you must understand what happens so that they can separate. Okay, so I'm gonna say the negative. Okay, let me write it here so I can see. The negative, the negative charge from B, repel away, okay, towards what? Towards the left. You see that it moved to the left, okay, towards the left, while the positive, while the positive charge migrate or migrate towards the right, towards the right, to do what? To attract the negative charge, to attract the negative charge from what? From C. That's it. That's why they touch each other. Then this is the reason why they separate after touching. Okay, I hope you got it. And then calculate the number of electrons transferred, the number of electrons transferred between the two spheres during the contact. Guys, it's simple. What is the formula? N is equals to Q divided by what? E. Okay, what is Q? Q is the multiplication of these two charges. Remember, initially it was 4 and 6. So we are going to use it. What are we going to say? 4 multiplied by 10 to the power of minus 6 multiplied by minus 6 multiplied by 10 to the power of minus 6. What is E? E is there in information sheet. It's 1 comma 6 multiplied by 10 to the power of minus 19. Just press your calculator to get the number of what? Number of electrons. And then 1,25 multiplied by 10 to the power of 18 electrons. That's all you were supposed to do on that question. Okay, let's continue. Go to question 4. Okay, question 4 says grade 10 learners want to investigate the relationship between current and potential difference. Their teacher gave them the following apparatus: a voltmeter, ammeter, connecting wire, and 5 cells. Write down the possible investigation question 4.1. What do you want to investigate? Investigate the relationship between current and potential difference. So my question is there. I can choose to remember your investigation question must start with how, what is, or yeah, how or what is, and also yeah, yeah. So Mina would like to say it like this: what is, what is the relationship? What is the relationship between the current, the current and what, and potential difference at what? At constant temperature. Difference, okay, at constant temperature. And then don't forget to put question mark. If you don't put question mark, your statement is no longer a question. You will lose a mark. I think you'll lose 1 mark. Okay? And then 4.2. Write down the dependent variable. Okay? So, guys, check. This is X, this is Y, this is Y. Okay? So always remember in maths, you're having something like this. This is Y, this is X. We always know that on whatever is in X is what is independent. Whatever that is in Y is dependent. Even here, we use the same thing. Okay, this is Y. It means ammeter. Ammeter measures what? Ammeter measures current. It means my current is dependent. Current. Okay, for 2 marks also. 4.3. What is a control variable? So guys, control variable, for a circuit to run, we must have current, potential difference, which is voltage and resistance. Did they mention anything about resistance? No, it means resistance is a control variable. So you can say resistance, or you can say what? You can say temperature, because resistance measures temperature is defined. Okay, then they say draw a graph of the current plot using the point. So guys, it'll be hard for me to draw, but let me show you. You are going to have something like this. So I can, okay, I will start here. I think I can make it compared to what I'm given. Voltmeter 1,5, 3, 4,5, 6, and then 7,5. And then this part, I will just put numbers randomly. It means I'm having, I will start by 0,5, goes with 1, 1,5, 2, and then 2,5, right? Ah, doesn't matter, you will see, but here you're going to have what? Your current. Remember, ammeter measures current. What about voltmeter? Voltage. So the graph, you know how to plot, but you're going to have something like this. It will start somewhere and move up. Your graph is going to look like this. It's just I can't draw it here. For 7 marks, you are going to do, and 1,5 will matches with 0,7, 3 will matches 1,5. You will have a straight line graph like this. Okay, and then so, and then they see from the graph, right, and they deduce relationship that exists between the current difference and potential difference. So guys, because my graph will be increasing graph, it means I will say 4.5 as the current increase, comma, potential difference also increase. Potential difference also increase. Or you can say, or you can say current is directly proportional to what? Proportional to uh, potential difference. Okay, so that's all we're having in this question. And then question 5, it says a circuit below shows two light bulbs, 4 ohms and 5 ohms respectively connected in parallel, as we can see here. Okay, and then to a 4,5V of voltage battery. Calculate the effective resistance. Is in parallel, we're going to use R parallel is equals to R1, R2 divided by R1 plus R2. Or someone can say 1 over R parallel is equals to 1 over R1 plus 1 over R2. So, I would like to use this one. What is R1? 4. And then R2, 5. So, 4 multiplied by 5. And then what is the answer here? Just press the calculator, which is 2,22 what ohms. That is my R effective. Okay, so let's continue. So 5.2, calculate the total current of the circuit. Guys, I have voltage. I just calculated my R effective here, which is 2,22. It means I'm going to say I is equals to V over R. What is my voltage? 4,5. My resistance? 2,22. Press the calculator. We are going to have 2,03 watt amperes. As simple as ABC. And then another question says calculate the amount of charge passing through the A2, A2, ammeter 2 or A2 in 10 seconds. So it's simple. Which formula are we going to use here? We are going to say we want current at first, right? So I is equals to V over R. What is voltage? 4,5. My resistance on A2 is 4. So divide by 4 and I'm going to get what? 1,13. So guys, this is the current that passing through A2. So we want to know the charge. So I is equals to Q divided by what? Divide by change in time. What is my current? 1,13. Q, what is my time? That is 10 seconds. And then you cross multiply. Therefore, Q, what is 10 multiplied by 1,13? That is going to be 11,30 watt charge. So this is my final answer. Okay, so let's continue. 5.4. It says another resistor is connected in series next to ammeter E1. How will this change the total current of the circuit? Write down only increase, decrease, or remain the same. So guys, when we add another resistor here, what's going to happen in total resistance? The R total is going to increase. Obviously, it will increase, right? So remember, current and resistance is inversely proportional to each other. So what's going to happen? When the current, when the resistance increase, current is going to do what? To decrease. And then you explain here. You see what? Uh, uh, if we add the other resistance, it means total resistance will do what? Resistance will increase. And then you can also tell them that current is inversely proportional, inversely proportional to what? To resistance, as like that. Okay, and then the other part question 6 and question 7 and question 8, you'll will see them on a part 2. Ne? So thank you so much. See you on the next video.